So this is open for you guys to ask questions. If you don't have any questions, I have some that I can ask. But feel free to jump in and I guess use the microphones when you ask them. So should I start? Yes, okay. So this is more for Lesley, Millar, and Bohr. When industry wants to adopt technology developed at universities, how does the company decide what is worth licensing, and then how does the university deal with the IP associated with that technology?
Okay, maybe I'll start. And first, I want to thank for the invitation to be amongst such esteemed colleagues. So how does a company decide what technology they might want to license? Well, first off, often companies are tracking what faculty are doing in their particular area of research or product line. And if it's an established company, clearly they probably have their eyes on particular research programs. So, sometimes we go to companies and say, and we're trying to basically market a technology. It's kind of a technology push as opposed to a market pull. And we say, what are you looking at? Cancer diagnostics, therapeutics, and they tell us, and we say, well, we have this faculty member, and you might say, well, we're already looking at them, we know what they're doing. What else have you got, or whatever. So it really depends. There's a multitude of ways it can occur, but more often than not, if it's an established company, they have an idea, and they're already looking if they're particularly interested. If not, then we are often going out and talking to those particular companies. And quite frankly, we don't sell technologies to company. We effectively are selling researchers and their research area, because the transfer of technology is actually about relationships, and it's about long-term relationships. And you can use a target shot and decide that that company might be perfect for this particular technology that we've just had disclosed to our office, and we might file a patent on it. But because of the ways of the market and the market risk, it may never come to anything. So what I'm more interested in the $600 million of research that goes on this campus, is finding long-term partnerships that allow us broadly to talk about what our researchers are doing, and then look for fits within the relationships.
So I'll provide an answer to that. I have to admit, I'm not personally aware of any specific patent that Intel has maybe gone to a university to try to license. And I answer that for two reasons. Number one, I don't usually get involved in that type of a discussion personally. But the other reason is that Intel often works with universities ahead of time to arrange a kind of a subscription fee, where we may pay the university a certain amount of money every year. That can apply to any patents that we may find to be useful to us down the road. So instead of negotiating on an individual patent basis, we usually just have a broad patent agreement with universities.
Question for Professor Gangbao. We were wondering, have you ever tried taking your research into industry, or has anybody in industry approached adapting your technology?
The answer is yes. So this morning I talked about how to use molecular beacons for isolating cardiomyocytes. So in 2003, roughly 10 years ago, actually it wasn't me. There was a fellow called, so Georgia Tech has an office called the Venture Fellow program. There's a fellow who is an MD, MBA. So he actually looks through the technologies in different labs, identify the molecular beacon technology as something he had a strong interest in commercialize. So he approached me. Then just within a few days of the discussion, we decided to form a company. The company is called Vivonetics. So, of course, as a professor, I didn't want to be the CEO, so he became the CEO. I was more the chief scientist. So initially, we applied for some SBIR, STR grants from NIH, was quite successful. So the company was almost bought by a larger company in California, but something happened. I guess because going through the university process of selling the company took too long, and in the end they lost patience. So then in 2008, we actually were trying to get VC money to maintain the company. The timing was not perfect, as you know. Then 2 years ago, the company ran out of money. So the company is still there, but essentially, I still wear the head of CEO, but there's no money, there's no personnel, it's just a name for now. Actually, I plan to close that company. But on the other hand, as I mentioned this morning, the iLisa we developed, that is the, I hope it's the next generation of ELISA. We do have a plan to commercialize that.
I do just have a general question, I think. As a second-year grad student, I'm obviously thinking about when I graduate, either industrial path or academia path or whatever. But my question is, I guess people talk about academia versus industry a lot, and my question is, how do the partnerships between the two make, I don't know, just kind of differ from pure industrial research versus pure academic research? And maybe just expand upon that, especially from the perspective of a graduate student looking for a job in the future.
Can you take this one? Well, I would say that first, in my opinion, there is no pure research, pure industrial research or pure academic research. It's just some sort of a mixture. I can talk a little bit about my personal experience. Of course, I also been through graduate school, and I was dreaming to become a physicist. And I did work for 2-3 years in a university environment, and then by story of the life, I crossed the river, so to speak. So I moved into industry. I have to say that it wasn't really a conscious choice. It's not that one morning I woke up and I decided to move into that path. I actually, for a while, thought a little bit how to do it. And at the beginning, I actually started building some gadgets, preamplifier, discriminator that I knew that some people knew. And I started selling them. And then, well, that was kind of fun. And I spent more time in industry trying to develop the company. So then going back to the research, of course, in a company you don't build gadgets that you don't know what to do for or with. And so the answer is always try to talk to people, try to talk to researchers, work with researchers, understand what they need and see if your expertise can provide or supply something that they need. In fact, in our case, from the little gadgets, we eventually design our own instruments, and now we have 5 major platforms that reach different markets. So going back to your questions, it's not so clear-cut. Now within ISS, although it is a small company, we're only 35 people, there are some people who actually a group of 5-6 people who are in design and development only. Of course, it's not the research that the researchers, the scientists carry out at the university. The design and development, we call it design and development rather than research and development because it's very directed. We want to reach a goal. We set a goal and we want to reach that goal.
So my experience at Intel, at least I should say our experience at Intel, is that research that's targeted for products that we want to manufacture in the next 2, 3, 4 years is best done internally at Intel because universities have a hard time doing that type of research or development at the pace needed to deliver a result in time. And And to do that type of work, to do the more near-term research, we have about 1,000 PhDs at our Hillsborough site working in various aspects of our technology. But where universities are very useful is helping Intel or helping our industry do long-term research targeted for 5, 10 years from now. Intel certainly doesn't have a monopoly on good ideas for what new ideas might come. And when you're talking about options for 10 years from now, there are many, and Intel doesn't even have the resources to explore all those options. So teaming up with university researchers to explore some of those longer range speculative options to help us narrow them down is I think where that collaboration works best.
I would like to add that if you become a professor, if you have a strong interest in commercializing the technologies, you can do so. So essentially what we do is every time we have a cool technology, we file a patent application, right, to protect yourself. If you get the patent, of course there are two ways. Either you license the patent to a different company and just leave it, right? Or you can form a startup company to commercialize the technology yourself. So in short, actually you can do both.
So I just have a follow-up to that. I'm Eric Woodstone. I'm a fourth year or fifth year student and a member of the Agri Training Grant. I was wondering about the difference in how funding is really achievable. And I'm not sure how much expertise you guys will have in how funding for a small operation might take wing, but perhaps from a larger organizational standpoint, I think many of us are familiar with the NIH and NSF model of funding, but relatively few of us have access to the kind of funding that maybe Intel or other corporations might put into their efforts in working with university researchers. And so you kind of touched on how these efforts evolve over time, but could you maybe more speak on how you isolate, how you isolate the good ideas for 10 years from now or 5 years from now, and what kind of, where does the funding for that come from? Some of it comes federally, but where does the company make its, how do you make your stake?
The old paradigm, at least the thought I had when I was a student here, is that professors are single individuals that have great ideas and do research and come up with great results. I think that paradigm, at least in my industry, has passed. It's long passed. So today, in the integrated circuit industry, the major companies like Intel, IBM, Texas Instruments, even some of the foreign companies like Samsung, we pool our money into an organization called the SRC, the Semiconductor Research Corporation. And that company, when they have research projects that they want universities to get involved in, they put out proposals, and they ask for teams of university researchers to respond to that proposal. So because the projects are so significant, the era of one or two professors at one university being able to do it is usually past. So the more successful proposals involve teams of some of the best researchers from across the nation. And actually, here at this campus, Naresh Shanbeg, Professor Shanbeg, is heading one of those research centers. I think he's going to be talking a bit about it tomorrow. But that's an example where he was able to put together a team of some of the best university researchers from across the nation, and it won this proposal. So it's a multi-year funded effort to explore a problem we're very interested in.
How does a company split that knowledge up afterwards if they all pool their money?
Sorry, say again?
Just on that note, how do the companies who pool their money into that split up the knowledge that's gained?
Oh, well, the knowledge is public. It's public, yeah. So all companies benefit equally from that knowledge. And I will say that, well, how do the companies who put the money into the effort, how do they choose which research project to fund? Well, it's done by a voting method amongst the companies. So they will look at the various research proposals that come into SRC, and the various company members or representatives will vote on, well, we like this one best, so the proposal second, this one third, and the proposal that gets the most votes is the one that gets funded.
Maybe I can add another aspect of this, which comes from what one might call the grand challenges of different industries, and particularly different corporations. And I'll mention a couple of centres that have launched recently at this university. And this is where, to Dr. Bohr's point, where there is an issue that the company wants to solve, or is looking 10 years out and it knows it wants to be in a particular market area, launch new product areas. And one centre that was recently launched was by Abbott, called the Centre for Learning, Nutrition and Memory, $50 million over 5 years. And it literally is a grand challenge that they're facing in terms of working out how cognition is impacted by nutrition. And I think of this as the Cheerios box that promises that this is going to lower your cholesterol, except there's no real scientific backed up data to go with that. And so this is one of the first centres of its sort trying to work out, how can nutrition help or how does it impact cognition. And so this is engaging, I think, our neuroscientists, our food and nutrition folks, as well as folks up at Beckman in multiple imaging areas and the like. And that was something that they targeted. So that was one specific pot of money. Another one is EBI, Energy Biosciences Institute, which is BP. Another one that they did with us, the International Centre for Advanced Materials. Again, it was all their money. But in a similar vein to the consortium mentioned here, Semiconductor Research Corporation, there are other consortiums that occur from within the university, and often they're matched with government funding. So, and this is a particular issue as we look at diminishing federal funding, as well as state funding to universities. And those centres, some of which many of the professors here are engaged with, IUCRCs, some of them are called, or SRCs, Industry University Research Centres. And the point of that is you bring some NSF funding in, for example, you pick some project areas, you recruit faculty, and then you recruit industry. And industry have to be interested in the research areas and the problems being solved, which to my mind means if they're going to spend money on it, they have to be problems that they're facing as well. And so those are ways that they mix the money. And you mentioned how is the IP set up? How do they, divvy the potential rewards? Remembering that this is all risk reward. You never know whether or not you're going to get something back based on the research you do, and that is all determined in advance through agreements. And pretty much, if the government is involved, there are standardised terms for those sorts of things. So there's all shapes and sizes and all mixes of money that go in, and there's different ways to deal with it. And basically, the universities pretty much set up mechanisms internally to try and deal with that.
Okay, thank you.
I actually have a follow-up question to those comments. So something that was touched upon was the IP, and Mark, you said that industry has funded this. Sorry, I totally lost the name of it. The centers, the SRC.
We pull our money in the SRC.
Right. So I guess in that case, it's not federally funded research, so you should be able to control the research, even though it's public. Could you explain a little bit more about that?
Well, we set the goals of the research, and we, of course, choose which proposal is the most interesting to us. And the research time period may be 3 or 4 years, and the researchers usually come to these sponsoring companies and maybe once a year to give an update and to solicit feedback. So the smart researchers know to solicit feedback and to adjust their research accordingly.
industry reconcile the need for secrecy and the need for open access? And this is also a question.
I suppose you do what you get paid for.
So maybe I can clarify.
Actually, without naming names, I will share the fact that there is at least one good professor at this university who is doing some very good work. To my great frustration, he won't publish it. So for the opposite reason you're getting at, that he sees a competitive threat in terms of his research and what other universities are doing. So I'm on the other side of the fence there. I'm telling him, why aren't you publishing, giving this university acknowledgement, and he won't do it.
So maybe I can clarify a little bit what is meant by open from the government-funded side. Federally funded research, there are requirements to get it out into the public domain. That does not mean open source, and it doesn't necessarily mean free. It does mean that the government want to see their funds spent in areas that are going to impact the world. And there is a law that I won't bore you with, called the Bayh-Dole Act, that was enacted in 1980 that gave universities the right to take title to federally funded research, which prior had not been available. It was basically vested in the government. And for a variety of reasons, not much was commercialized. But the impact at issue is that they want the research to be transferred to be used by the public for societal good. And we have an obligation to do that. In fact, we have a timeline to do it, and we have federal compliance to show that we were doing that. So if ever a faculty member comes to us and says, you're not doing anything with my IP, you've chosen not to patent it, I would like to do it, then I have an obligation to transfer it back to them, but they then have the obligation vested in them to commercialize it or to make sure it goes out into the public. And that might be that they say, I'm publishing, it's free, everybody can use it. On the other side, and what my office does, is take that research, and as described before by Dr. Bohr, was either start companies, assistant starting companies, or transfer it into a company to try and get it into products or services. And many of our faculty here might actually start consulting groups. They may not actually license technology from us. They're using what one would call kind of trade secret information. They're using their consulting part of their brain. So there are a multitude of ways that technology can be transferred, but the tension between trade secret and open only comes into play almost in the scenario that you described, which is if somebody decides not to publish or is forced not to publish by a company, and then there's great tension in the academy, because the whole idea is that at some point you will publish, and that at some point somebody will graduate with a thesis, and they will be able to publish that as well. So we are constantly managing that process, because we will not prevent publication, and we will not prevent somebody from graduating just because we're trying to file a patent on it. So there's a whole lot of issues that come into this, but there has to be really a clear understanding of the fact that federal government is spending $1 gazillion a year on research being carried out at universities, and it doesn't want it sequestered. It wants it out for the public good, to be used by the public in a way that will advance society and yada, yada, yada. That was technical, that last bit.
So I think the short answer is more complex than they'd like to think of.
That is so succinct, yes.
I have one question, and I think it's great that we have a panel of industry professors and also someone from tech transfer here to answer this. I was always curious, there's always I think you touched on it where you say professors are frustrated sometimes that there's not action on what they're doing. Of course, professors may not think something's valuing tech transfer, there's always dichotomy there. And I'm kind of curious, how do you identify those technologies? Because I always think back to the story of Paul Latimer and Paul Mansfield. Paul Mansfield, they both won the Nobel Prize from Orion. Paul Mansfield's rich because his university patented his ideas, and Paul Latimer didn't really get anything out of it because his university passed on it. So I'm kind of curious, how do you all balance the idea of investing, protecting your IP versus letting it go and saying it's not worth the investment?
I don't want to hold the panel, and I know there's Dr. Bow is from a university, so I don't know if you want to comment first.
Right. So typically the process is the following. If we see a a novel idea technology. So we basically, before we go to meetings to present to the public, we file a disclosure. Right? So a standard form at Georgia Tech, you file online. It's quite simple. So after that, Georgia Tech Transfer Office would evaluate that to decide if that is worth patenting or not. Right? So we essentially go through so-called the current literature, right? The art. So they'll check if this kind of idea has been patented or published. Right? They also look into the content to see if this is really something significant or it's trivial. Right? And they make a decision. So if typically they could make a decision within a few months, like 2-3 months, to tell us if you need to file. Either the university will file the provisional patent, after which you have a year to file the full patent application, or they would just tell you, look, we decided not to pursue this further, we release the rights to you. So if the research is supported by the NIH, for example, right, then if the inventors want to get the rights, and the inventors will need to ask the NIH to release the rights to them. Of course, the inventors could decide to use their own money to file the patent anyway. But that's not usual. The usual case is the university would essentially pay the initial patent cost to file the patent.
In our case, it's much simpler. It boils down to money. And if we have a technology that we foresee will cover, let's say, 20 instruments per year, we might decide not to file a patent, because the cost of the patent is fairly relevant. If, on the other hand, we see that the technology might be useful and for us for the next 5 years, 10 years, and we see value, then yes, we invest the money.
Another perspective from industry, here at Intel and other companies too, Intel strongly encourages its engineers to file patents, but those patents all belong to Intel. So I don't know exactly what the rules are in university, but we should all realize he who pays, owns the patent.
Yeah, so from a university perspective, we pay in terms of, it's not the obligation of the inventor who discloses to us, and we own the IP, and it is assigned to us. But we share, probably a little more than industry does, 40% of revenues go back to the inventors after we've covered our costs. Now, don't get excited.
I get a plaque.
You do? You do? Well, ours don't usually get a plaque, so, we can trade the cost of that. But there's a couple of things I'd like to kind of highlight here, because it does also come down to money for universities, and particularly that's a particular pain point for many universities. So we have this grand mission that states economic development, and that is basically the auspices under which I operate: economic development, impact, startup companies, licensing, some sort of revenue. And thankfully this is not a university that beats me around the head every day and tells me that I should be earning $100 million at the university. We are bringing in modest revenues, about $5 to $6 million a year. We are spending $3 million a year just on patenting. And that's not on patenting just for the invention disclosures that I get in year to year, which are range between 150 to 200 new inventions, new ideas. That is the culmination of years of investment. And as many of you probably know, the patent system is a slightly bit broken at the moment. They're working on fixing it, but it takes upwards of 42 months now, I think, to get a patent issued. And in that period of time, they're not, well, yes, they're probably sitting on it for 2 years, but then they begin to have a look at it and decide whether or not there's prior art, and then you have to get lawyers involved. So for a good US patent, you're talking anything from $18,000 to $25,000. anything abroad, anything in national jurisdictions, you're talking anything up to 50 to 65, depending on the country you're going into. So for a good patent portfolio, you could be talking hundreds of thousands of dollars. And then when the questions that we've had about how do you get people to be interested in this technology, well, you have to do a lot of legwork, or you have to make sure that you only invest in the technologies that you know somebody is going to license. And that is impossible without a little ball to gaze into daily. And I wasn't given that when I was employed by the university. So there's a lot of cost involved, there's a lot of risk, and it takes money to do this. And we need to balance those risks and balance the costs to make sure that we do the best with what we've got.
Can I ask? So I have two questions, one for Dr. Bohr and one for the other members of the panel. First for Dr. Bohr, this is so as an academic institution, there's a continuous struggle during the faculty's evaluation and promotion and tenure process of focusing on research and publications, while the other domain is for commercialization of technologies and the like, and engaging in other activities besides the regular education and teaching mission. So how do you and the University of Georgia Tech reconcile, and does any of this play a role in the promotion and tenure process? And I would throw the second question out also to the rest of the panelists. There's an alternative view to filing for patents. There's a large segment of the population, or at least some segment of the population, which feels that knowledge should be open and for everyone to avail. And why do we have to patent? And I would like you to answer that after Dr. Bohr answers.
Yeah, so that's a great question. So we actually constantly discuss this issue because the truth is, of course, Georgia Tech encourages professors to file patents, to have startup companies to do commercialization. But then comes down to tenure decisions. I think it could still be risky because I've been serving on both departmental level and college level tenure promotion committees. If you look at a specific candidate with a specific package, of course, usually the two things that are very critical, one is funding, the other is publication, right? So if the person has a relatively weak track record in funding and publication, then the person spends a lot of time in commercialization. Would you tenure the person? It's hard to say. I would think, of course, it varies from person to person, but still it's pretty risky. So usually my suggestion to my junior faculty members is typically you focus on research, focus on publication. Of course, you need to do a good job in teaching before you get tenured. Then after you get tenured, of course, if you have a strong interest in doing commercialization, that's fine. So that's the typical answer, right? But of course, there might be exceptions.
So then your next question was, well, why do we have patents? Why can't information be free to society? And I think the whole reason why the Patent Office was set up, however many hundreds of years ago, is because companies who invested in developing an idea wanted to have some chance to make profit from that idea. And if companies aren't protected, then they're not going to invest in developing new ideas.
And I think that's a particular issue in certain industries where the costs for development are extraordinary at the front end. So that the development of the technology requires that protection over the life of the term. I mean, patents over 20 years, but even that, some products are only developed at year 19, and it takes an enormous effort to get that money back. So you have to question, you have to look at the innovation system and motivating people to continue to develop in areas that they wouldn't unless they had some protection for a period of time. And I think there are certain domains that may survive without patents, and then there are others that really need some sort of protection to ensure that investment will continue and new ideas and innovation will continue as well.
What about healthcare? Healthcare. So specifically healthcare, that's a big issue.
Yes.
Yeah, that is a very great question, and it touches a problem and an issue that we are all aware of. Throughout the years, in the past few years, we faced the issue with the drugs for the HIV virus. So, can other countries produce these drugs? And so, just to say, malaria. Personally, I think that the patent system should stay in place, but this social issue should be addressed at a government level. And I would like to see government entering into a special agreement where they would somehow, I use the word compensate, but maybe it's not the right word, but they would transfer some of this product to other areas of the world where they are needed, definitely so. But at the same time, we cannot deny that there are costs involved in developing some of these products. If Intel has 1,000 PhD, I guess at the end of every, or in the morning, they have to have breakfast. So.
Well, actually, there are very different situations between the drug industry and the integrated circuit industry, which both use independent patents, but in different ways. And my impression is in the drug industry, it's kind of a, one winner takes all. But if they spent $100 million over 10 years to develop a drug, they want to be able to get that money back somehow, because that one drug was a success, but there were 20 others that they also spent $100 million on and failed.
That's the problem.
Now, in the integrated circuit industry, it's a very different situation because all the major companies, Intel, TI, IBM, Samsung, we all have a few thousand patents, and if we started suing each other, the only people who would get rich would be the lawyers. So we generally take have a peace treaty amongst each other, unless there's some really egregious patent violation. But it's a different situation in integrated circuits versus the drug industry. And I guess people can live without an Intel microprocessor, but I'd like not to believe that.
Well, to follow up on that just a little bit, I heard it mentioned that the patent system is broken, but maybe on the road to recovery. I think a lot of people who listen to such things sometimes are aware of through patent wars, companies buying up other companies' patents, and overly broad patents that, again, does result in a lot of lawyers fighting, of course, but companies fighting other companies. I just wonder if you would address maybe what you feel, maybe it's something that you know that I don't know about, what is being fixed on the patent system, because it does seem there's some areas that where they need work.
Okay, I was probably referring more to the administrative processes than the detail of the patent system itself, because I think what you're referring to is the kind of trading going on between entities who are buying up large swathes of technology, and those entities who are buying them are non-practicing. And if you describe a university, we're non-practicing, but we, with the best will in the world, we're actually trying to have impact through the research that we're doing. And so our issue is not to go out and sue the behind of everybody, because one, it's not what we're here to do, nor do I want to do that with somebody else. Basically, we get a call probably every week from someone who wants to buy patents that have been sitting on our shelf and would like to take them, and then they say, and we will go out and enforce them. And well, quite frankly, if I wanted to enforce them, I'd be doing it myself. So let's move on. So to your more specific question, about the patent system and the way that works. I think that's less about the patent system and more about how people are using patents. And unfortunately, some people have spent a lot of money and then decide that well, they can't do anything with them, or they're not core to their business, or there's a big sale to another company, and they see enforcement as a way to go. And that might be a naive view, but I think the way in which people are utilising the patents is something more in some ways than the patent system itself. I don't know what you think. It's a great question.
I had one follow-up question for that. I heard recently that they've been making legal changes to some of the how the patent system works, especially in terms of like how they grant patents. I think the phrase they throw around is like from first to invent to like first to file. And I always want, I've been told by some patent attorneys, they're very scared of that, especially from other university details. I heard scary statistics on it, like Intel, not Intel per se, but companies like IBM and HP, they're filing patents at a rate that's amazing. They're getting patents on the order of 1 or more per day on average, actually granted. If we switch from something where it's more about how many patents you can file versus how many ideas you can invent, how does the university compete in that market, since we don't have armies of lawyers like some companies do?
Are you trying to compete with us?
Well, that's what I was just about to say. I'm not sure we're competing. I would like to think that we're trying to partner with the industry people, because we are not manufacturers. We are not practicing entities. We are transferring knowledge, first and foremost through graduates, students, and other professors at times. And then we are trying to transfer all these cool ideas into the marketplace. So the first thing is that I don't see us as competing, and certainly I don't have the budget to compete with an Intel and an IBM, nor I think that would kind of step away from what our mission is. First to file versus first to invent. Yes, it put the fear of God into a lot of people, because the whole idea behind that basically is that before, the US, which was out of kilter, out of step with the rest of the world, still allowed the first person to invent to basically log that in their logbook, and had a year from publication if they published in order to file. And we still have a grace period, so now they're saying actually you have to file, they will look back at who filed first, and if somebody derives from your work but you didn't get to the patent office, then you have to prove that. There's all sorts of stuff about derivation and derivation proceedings and the like. Yes, there are people who've been rushing to the patent office, but again, we have to get back to the fundamental premise of what we're doing. We have $600 million worth of research on this campus. We have top researchers, and what we're trying to do is take that research and have an impact. And where it is appropriate to file patents, we try to do that. And because of the new rules, we will work within the rules to do that. If it's not appropriate, or we don't think, and we're not questioning the science, is that we just cannot make the business case for a particular technology, we choose not to patent it, but we may transfer it. We have taken technologies and we've not patented it, and it's now in small startup companies, student or otherwise, and it's out in the nether regions in developing countries, and they're creating cool new products for developing communities. But it is less about the fact that we're racing to the patent office to get many things patented, as looking at what's coming in and working with the faculty to disclose to us as appropriate.
And to a degree, my experience is that there's some game playing going on in the industry. About the universities, about patents. Some companies just like to brag about how many patents per year. You look at some of those patents, and they're pretty worthless. Sometimes I wonder how on earth did they get a patent for this idea. So at Intel, we don't have an unlimited budget for patents. Even Intel, they screen all the patentable ideas or the patent submissions, and they say, well, we'll actually file this one and this one, but not these others, just because it's not worthwhile.
So we have a follow-up question actually to all the patents and intellectual property. So here at UIUC, and you guys have seen, there's a lot of nanotechnology that's being developed. And so we were wondering how nanotechnology innovation will ensure that the U.S. is competitive in advanced manufacturing and biomedical
That's a big question.
I guess where would you like to see the technology go?
Yeah, I'm not a biomedical expert, so it's hard for me to comment on some of the papers I saw today. You really should invite more industry reps from that industry to this type of forum to get their feedback. I can talk to you about transistors. I can talk to you about drug delivery systems.
But there were a couple of talks, excuse me, today, showing how the detection limits of some molecules can be improved and have been improved. So can I detect a cancer molecule when in the body I have maybe 1 picogram per milliliter versus the current sensitivity limits, but which are much higher? That will increase the healthcare, of course, because we can capture at the beginning, at the inset, the presence of the cancer. This is one area that will improve a lot the healthcare system. On the other side, there are all the developments in the wireless, in the transmission, in the telemedicine, in the point of care of the health. So the capability of providing patients with gadgets that are inexpensive, that they can be in contact with the healthcare provider, with the doctor or the hospital. So I think that we are moving into that direction, and this is something that will maintain definitely the United States or countries that will be able to develop and keep going into this direction ahead.
So maybe I can answer that too from the perspective of practically whatever the invention is, and this applies whether it be nano or other, but looking at what we're dealing with when we get new disclosures into our office or any tech transfer office from a university, they're pretty nascent. And to have impact and to transfer them out, you need to make sure that you are doing some fundamental things, and to Dr. Bohr's point, you need feedback from industry about the problems that they're facing, so that what you've got is a cure without an illness, or a solution without a problem, and that you're actually addressing what industry wants and needs, which is why you need feedback and information, and you need to, if you're really wanting to have that impact, you need to have that influence in your research. And within the system of the university, because of the nature of markets which are fairly risk-averse and becoming more risk-averse, you need to find alternative sorts of funding to move those technologies from a research phase to a translational phase before it actually goes into either a company or a startup company or into a license. Because technologies tend not to pop out of a university into a product. Often a piece of software may, we've had a few of those recently, but it is going to need an enormous amount of further development. And just as an example, when drugs are the easiest often, for $1 worth of research done at a university, you need $1,000 more before it gets into an actual drug, or it becomes a drug on the market. And you can scale that back for a number of different applications. So what universities have to do, and this university has done fairly successfully, is build a system of resources that can be applied to that, be it entrepreneurs and residents to work with faculty interested in startup companies, an incubator to help with the startup companies themselves, support for writing SBIR, STTR grants for those small companies, access to NSF funding that is doing that translational thing like the I-Core program, other mechanisms by which they're providing support to give support services to faculty who otherwise would be working in the lab, or, as it happens, and talking about another transfer, postdocs who are deciding they don't want to go into industry, nor do they want to continue to be a professor, but they would love to do a bit of both, and they become the translation, the transfer into a small company and become part of that small company and actually transfer the knowledge with them. So putting all of those things together, different flavors, different shapes, depending on your environment, really helps research become reality and have impact. And I think knowing that and getting the feedback early on about how to direct some of the things and know when to stop doing something, they call it, failing early, on things that industry is not interested in, or you just can't get to scale up or do what you need it to do for it to be a viable option in the marketplace.
So in terms of nanotechnology, if I remember right, the numbers are three different numbers. One is the investment, the second paper published, the third patent filed. In all three areas, of course, the U.S. dominates the whole field. So I don't remember the exact fraction of parts of the world, but definitely U.S. leads in this field. In terms of application in the medical field, I think there are already a few nanotechnology-based drug carriers are being commercialized. There are quite a few in the clinical trials, phase 1, phase 2, phase 3. Of course, there will be more moving into that phase. So I would think the first 10 years or so, that is roughly between 2003 to this year, this 10 year, we have done a lot of basic research. We have been trying to do translational research. I would think the next 10 years, we'll see a lot of commercialization.
Now, if the question is, what is the value of the nanotechnology, bioengineering work going on here at Illinois to industry? Well, in my view, the only way to answer that question is to go to industry. Don't wait for them to come here. Don't wait for them to read your papers. Go to the conferences that they present at. So you not only see what they're working on, but hopefully try to present your own work at their conference. And then you have a chance to establish a reputation for Illinois in that type of industry forum. And then they'll come here, and then they'll say, how can we fund you, or how can we get results from Illinois?
So, I want to ask from the drug discovery point of view, what are the different types of fundings that are available for a startup, especially good and bad sources of funding? If you have a technology or product that you want to develop for a long period of time, so maybe you want to avoid what venture capitalists, which are more difficult venture capitalists, I guess these days. So
on that, I guess the federal government has different programs. The SBIR and STR. So like NIH, there's a Congress mandate of having 3% of the total NIH funding dollar amount being allocated to STTR, SBIR funding, 3% of the total. So I guess NIH funding now is roughly 30-some billion per year, right? So 3% actually is not a small number, although it's 3%. So I guess similarly, NASF and the DoD all have these programs, right? They set aside specific amount of money, although I don't really know if there's a fixed percentage. So based on my experience, if you apply for an NIH grant, if comparing the typical review panel or the typical program you apply, actually it's relatively speaking easier to get SBI or STTR funding.
Well, all I can say is that the SBIR program is great. Our company benefited a lot from this program. We actually designed and introduced an instrument using those funds, the phase 1, phase 2, and we got the phase 3, the clinical trial. But the SBIR grant may not come. So if you have an idea, if you want to start a company, my suggestion is really try to see if you can sell something. And I know that sometimes this is not possible, it's not feasible, but especially if you are building devices, items that can be of use to somebody else, most likely you might be able to interest somebody in using them. I have a friend, and he is in one of these positions. He's currently at university, and he built a nice gadget. I just call it box. His problem is that he's a perfectionist, and what I tell him is that well, perfection is divine; it's not human. Of course, we would like to build something like all the products that Apple builds. We learn a lot about Steve Jobs, position in the perfection of the products. And we like to look at the perfection in other products, in cars, in motorcycle, in a bicycle, wheeler. Yes, when you start at the beginning, you might not be building the perfect product. But still, you might find somebody who is interested in a prototype, and yes, you might be open to this person, to this researcher, and just say, this is just a prototype. The software might have some bugs, but I'm here and I can help you out. You might be able to sell a few of those. You might be able to generate some cash. Cash, at the end, is all you need. Of course, you can apply, you should apply to the SBIR, but and if they come, great. If they don't, you still have cash coming in on the side.
We have time for one more quick question.
Okay. So speaking from a student perspective, especially as a first year and somebody who likes to have sort of this 10-year plan, like, oh, I'm going to do this, this, and this, and I'll end up there kind of thing. I was wondering if you could comment on what kind of preparation you look for, one from maybe Professor Gameau's perspective, how you prepare students who, if they're more interested in industry or academia, if you encourage them to take different opportunities, and then maybe from an industry perspective, if you're looking for something specific during the graduate student experience.
Right, so we have a few different formats. The Tiger definitely is perfect. It's really, I would say the perfect model. Actually, I have a graduate student in my lab. He actually is in the Tiger program. He has been leading a team based on the idea in my lab to develop a business plan. Then, actually last month there was a so-called boot camp at Stanford, attracted more than 100 teams from all over the world to present their plan for commercialization based on technologies. And amazingly, his team got number 4 among the 100 or more teams. So I think that's a very good model for training graduate students who want to either have his or her own startup company or to go into industry, right? So that's one thing. The other thing we do is, of course, for graduate students who are interested in internships in industry, I always encourage them to apply, to spend a few weeks, maybe months or 2 in the summer, to actually work in industry to get the experience.
In a small company, you're always looking, of course, at the expertise, but you're also looking at some personal qualities, characteristics, and I would say that one of the most important is the flexibility. Just because it's a small company, if you come in and you say, okay, this is my task A, well, in 3 weeks you might be moving, or you may be requested to perform task C. Are you ready, or can you take that on?
So if you want my opinion of the difference between being a university professor versus an industry researcher, here are maybe some of the pros and cons. In a university, clearly you have more control over what you work on. You may have a couple different research directions, and you get tired of one, you probably move on to another one. In contrast, in industry, you are part of a team working towards a goal. You must deliver a project or a result. In university, I imagine you're spending half your time looking for money. At Intel, you have some of the best labs and all the wafers you want. So there are pros and cons.
With that, I would like to thank our panel, Lesley, Millar, Mark Bohr, and Barbieri, and Professor Gameau for your time.
And with that, we conclude and head to the poster session. So thank you, and